So the report, Our Common Future, got success. Why? And there are a couple of readings that explain why this report had success. And the sustainable development, according to many, is about economic growth. The environment must be treated properly. And so there was some criticism because many environmentalists say it's impossible to have growth and at the same time respect for the environment. But at the same time, economists appreciated very much the report. And actually, one reason might be, according to many authors, is that growth is still there. And at the same time, according to some, it doesn't imply major redistribution from rich to poor. Again, this is a kind of interpretation. Because if you read the report, you would say that it implies major redistribution. Because the stress on equity is very strong. But usually people don't read documents, don't read the papers. And so many economists and many other people stressed the importance of growth, the importance of intergenerational equity, and the issue of infragenerational equity was not stressed, didn't pass. Okay, you have a paper, and what is the major message of the paper? And so everyone read the paper according to his view. And so this is the reason why I insisted very much you to read the paper. Because in the paper, the stress on intragenerational equity is very strong. But the message that passed to the general public and also to specialists is that the most important is intergenerational, the welfare of future generation. Okay? So if you read this report in terms of importance of future generation, and also you can say that it doesn't imply major redistribution from rich to poor. And it opens up a lot of opportunities for making growth more environmentally friendly. You have heard about green growth. Okay? We have to make growth greener, so we can have a lot of wars, a lot of transformation and changing world. And it was mainly the standard messages of economists, which says that the issue with environment is correcting market failure. Do you know the causes of market failure? We have this model of perfect competition. Perfect competition is very good. Is the heaven is, but we have some market failures, which are imperfect competition. For instance, monopolies. If you have a monopoly, then maybe the result is not an optimum, a Pareto optimum. Maybe you have contestable markets, and so even if there is one monopolist, then if there is a potential entrant which is very strong, then the monopolist has to act as if it was in perfect competition. But usually, monopoly is a cause of market failure. Public goods. When you have public goods, we know that we have market failure. The market doesn't work. Externalities. So what is the standard point of view of the economist? The environment is a public good. Pollution is externalities. And so we need to correct market failure for environmental externalities. And individuals must bear the cost. Okay? And so, in a sense, our common future is a brilliant political document because it's a compromise document. It has little criticized, and everyone was happy with the concept of sustainable development, even the economist, and actually growth in the report was not only confined to the developing countries. Also rich countries, according to the report, could continue to grow. Actually, we have some drawbacks. Have you ever heard about pollution haven hypothesis? And N is missing here. The following two are criticism to what happened to the growth in highly industrialized countries. Pollution haven hypothesis is that Italy doesn't pollute just because it sends the dirty activities to Vietnam or to Turkey or to developing countries. For instance, dismantling the boats, the ferry boats, or very polluting boats at the end of the life. Usually in India, they are specialized in dismantling, or in Turkey as well. And it also depends very much on how you do this process. No? And this is a pollution haven hypothesis. Apparently, the developed countries are more greener, but just because there is a transfer or more polluting activities in developing countries. And then we have also, as a criticism, this Gibbon's paradox or rebound effect. We will see more specifically this. And the idea is that even if I become more efficient, this does not imply that I consume less. Actually, the opposite is true. The more efficient, the higher the consumption. And this is called the Gibbon's paradox. And we will discuss more in future lectures about that. This is a very famous report, Limits to Growth. And actually, this report was very criticized. What was done in this report? In the 60s, we thought about the famous trickle-down. Economic growth will benefit everyone. Do we need to have a different share of the pie in order to improve poverty and so on? No. It is just thanks to economic growth. Okay? For instance, and the poor, this is a pie, and how can we improve the poor? Without taking away from the rich, just making a bigger pie with growth. So in this case, you can imagine that you give most of this pie to the poor, and you don't take away from the rich. And this is a pie of the rich, the part of the pie of the rich. Okay? Now, okay. So the idea in the 50s is economic growth to solve poverty and to solve the intragenerational problem. And this was an idea that was working for a while, and now, as you know, it is not working anymore. I mean, at least in rich countries, inequality is increasing. But at the world level, maybe, I mean, there has been a lot of improvement from the developing country. And so growth was seen as very important, economic growth. And so the idea is that, however, the planet is finite, okay? And actually, we will see that at the end of the 60s and the 70s, the environmental movement was very strong. And so these people started with one of the first computers in 1972. They did some simulation. Now you can do this simulation also with your laptop or maybe even with a tablet. But at that time it was a very famous work because they did this work about simulation, computer simulation. And then the premise is that the environment is a thermodynamically closed system. We have resources. We live within a finite planet. And the economist, this famous economist, defined this book a brazen, impudent piece of nonsense that nobody could possibly take seriously. And this reaction was very provocative, but actually most of the economists, or perhaps all economists, thought similar things. And what was the reading, again, of the limits to growth? What was the current interpretation? The world economy would collapse in the 21st century due to exhaustion of the stocks of the mineral resources. This was the main message. Okay? But it is not true. This was not the main message. This was the main message if you read only the first chapter. And it was not even the main message of the book, because the book is not about the book is a simulation, so it's about scenario. And scenario building is completely different from making predictions. Is different from scenario building. The book was a book in scenario building. Now we will see why. And what was the book? And actually, many economists, many years after, say, look, your prediction was wrong because the world has not collapsed. We still have a lot of resources, and so on. So it is true that this book was nonsense. And so these known reserves are generally higher than were in 72. And so the book was a proof that there are not environmental limits to growth. And of course, you can have a book, have an article, and read and give a completely wrong interpretation of it. You can give an account that is not in the book. I mentioned to you that sometimes ago, rather recently, I found a quotation, a mention to a paper of mine, which was nonsense because it was saying Luzzati said this and this and this. I never said that. And what is the perspective of economists, of economics? Prices. What does it occur if oil is scarce? The price of oil will increase. And so we will use less oil, we will move to another technology, and so on. So according to the economist, prices signal scarcity and drive innovations. And of course, as I told you, if you read maybe the first chapter, then you could have this idea. And actually, in the first model ran. So in the first model, we have a collapse. We have a collapse due to resource depletion. Okay? This was only the first chapter. Then we have a second chapter. A second chapter, the resource availability limit was increased and no collapse anymore. Okay? And since we had in the second simulation, there are a lot of resources, the scenario is not a collapse scenario. However, there was another limit. Of course, pollution. Okay? And, okay, we have enough resources, but we have pollution. So pollution can be a kind of cause of collapse. And then they did a lot of variants, different try. And the most important issue is this distinction between prediction and simulation, scenario building. Disaster was not was inevitable. No? Was not inevitable. Huh? The issue is that how we do scenario building. So we do some hypotheses, and in this simple model, the idea was, if we don't do anything, and if we use the same coefficient as in the past, what will occur? So this is not prediction, okay? It is just saying what will occur if we don't do anything, if the state of affairs go on as in the past. Okay, it's not that I am predicting. You can imagine a differential equation systems with parameters. And then you build a model that can explain the past 20 years. And then you can just extend the model for other 20 years with fixed parameters, the parameters that you have used to reproduce the world or the system until now. And then you say, look, if nothing changes, in 20 years, population will be 15 millions. Okay? I'm not saying that, I'm not predicting that in 20 years the population will be 50 billions. I'm just saying if things continue like that, as in the past 20 years. Okay? It's just a model based on assumptions, which is completely different from prediction. Because when I do some predictions, I also, in some sense, have a guess about the values of the parameters of the equations. I'm not saying that the world will remain constant, as it was 20 years ago. Okay? And of course, it says it is possible to change these trends. So the idea is that if we keep on this path, then things will go bad. We need to change. It was not saying that the world will collapse in 2000. It was saying that things will become very bad. And so the idea was not to assign a prediction value to those. Of course, the environmental movement took it as prediction of the catastrophe, prediction of the collapse. So many people in the environmental movement says, look, limits to growth says that we are collapsing. And of course, the Western society didn't collapse, and so Brundtland report was nonsense. And so, in a sense, I publish a report, and everyone is interested in changing the meaning of that. And so the main message of the report was, we have to do something. And actually, moreover, we had this, okay? We need growth alone is not enough. Because, of course, if we have limits, if we have pollution, and so on, growth alone is not enough. Again, on the basis of our hypothesis. And you have to notice that what is the method in economics? The method is just hypothesis and deduction. No? Hypothesis and deduction. So actually is a standard method in economics. And, okay. And it was interesting that like 15 years ago, after the Brundtland report, the limits to growth report, the Brundtland report got a much better, what do you say? Was much better accepted. As we saw, the Brundtland report does not require to stop growth. And actually, this was a bit a message of the limits to growth. There are limits to growth. We cannot grow as we grow in the past. Developing country can grow, but rich country have to stop to grow. And this was one message of the limits to growth. Brundtland report says it is not very clear about growth in rich countries. What has occurred? Those are some pictures, and we will discuss more in detail in the future. We have experienced exponential growth. Now we will discuss about a technicality. So this is United States, Brazil, and China, India, and as you can see here, this is China. Okay, so one could think that all the countries sooner or later will have some exponential growth. And so the issue is, can all countries have this exponential growth within the planetary boundaries, the boundaries of the planet, the problem of pollutions? Do you know this difference between linear and exponential growth? This is a paradox, I think. It's very strange. And so this is very important. You can take two processes, the green process and the red process. Okay? I don't know. It is in Italian. The first process is yt, our variable, and t is time. And the second is exponential growth. Okay? Could you say that the first process is not growing? How would you define this one? Do you have growth here or not? This is time. Okay, time.
It's growth.
It's growth. Is it growth or not?
Times.
How many of you think that it is not growth? Please raise your hands. How many of you think that this is growth? Please raise your hands. All of you believe that this is growth. Okay? Thank you. Is anyone thinking that this violet is not growth? Yes. Why? It's not growth.
I don't know that growth is more irregular. It's not just like that.
Yeah, of course, irregularity. So cycles. Of course, we can think that we can have cycles here, or we can have cycles here. But in all cases, suppose that these are number of rabbits. Is the number of rabbits growing? In both cases, it is growing. In one case, it is linearly growing. In the other one is exponentially growing. When we talk about economic growth, what are we talking about? You know, in China government has big problem. There is a big issue in China because growth rate are becoming smaller. Okay? When we talk about 2% growth, well, we are talking about exponential growth. If we calculate growth rate for those two processes. So you have this, okay? Let's calculate the tassi di crescita. Tassi means rate, so we can do some Italian lecture. Tassi di crescita. Crescita means growth. Growth of rate. As you know, in English, the position of the words is opposite as compared to many other languages. Then I will ask you about your language. Do you say rate of growth or, as in Italian, tassi di crescita? In French, they say, as in Italian, in Spanish as well. So next, I will ask you about your language. But now, if you calculate the rate of growth of the red line, we have a constant rate of growth. For instance, 2%. If you calculate the rate of growth of the linear growth, you will have a decreasing growth of rate. You will observe that every year the rate of growth is lower. Okay? From economic point of view, we say, that's terrible. Our rate of growth went down from 4% to 3.5%. That's horrible. Okay? The economy is going to collapse. Okay? So according to economists, the linear growth is not growth. If you calculate the rate of growth, what you have to do, the rate of growth is the derivatives of y respect to t over y. Okay, are you with me? So what is the derivative of y? The derivative of y is b as with respect to t. Okay? This is derivative of y, b. What is y? Y is a plus bt. Okay? Y plus bt is y. So, if t goes to infinity, this growth of rate will go to 0. Okay? So, the higher t, the lower growth rate, but still positive growth rate. Okay? And what are we talking here? The derivatives and the rate of growth, as you know, is R. Okay? Because the derivative is R times AERT over AERT. So, when we talk about constant rate of growth, we are talking about exponential growth. So this is the critical issue. It's not whether we can have linear growth with given resources and given capacity of absorption of waste, pollution, and that, but it is if we can have exponential growth. In economic growth model, we posit that we will have in the long run positive constant rate of growth, which means exponential growth. So the reason why limits to growth was developed is actually this. Can we have exponential growth? And actually nothing in nature grows exponentially. There is only one thing that grows exponentially. You know what? Population doesn't grow exponentially in nature, unfortunately. Wolf population or wild boar population doesn't grow exponentially. The only thing is cancer cells. Cancer cells, they grow exponentially. Cancer cells. And of course, then you die. Okay? Then there is exponential growth of cancer cells. And this is a typical example from people from natural sciences, and they accuse economists. Look, you are dealing with something that doesn't exist in nature, and if it exists, you cannot have explosive trends in nature, because after the explosion, then there will be some collapse or something. It will end. You can have exponential growth for a while. Okay, cells can increase exponentially as long as they have some food, but then something will happen, and the population of cells will stop growing. So we need to be very careful about the difference between linear and exponential growth.